Algebra 2 students, how you doing today? We're working on section 8.5C, and these are called jobs problems. They are in the section rational equations because when you write your own equations that involve jobs, they do end up being rational equations, just like you learned to solve in 8.5A. The cool thing is, though, is once you write your own equations, they are easier to solve, some of the easiest rational expressions to solve. So let's take a look. Today we're going to be looking at jobs problems. This actually comes up in real life quite a bit. Is, what if one person can get a job done in a certain amount of time? Another person can get the same job done in a certain amount of time, either more time or less time. What happens when they work together? How long does it take? This is really kind of important to know when you need to get a job done and you want to know how many people you need to get it done in a certain amount of time. So let's take a look at number 1. Norton can mow a large lawn in 4 hours. When Norton and Jesse work together, they can mow the same lawn in 2.5 hours. How long would it take Jesse to mow the lawn if she were to by herself? So it turns out that if two people are working together and you add their rates up, that you get a total rate for getting that job done. So on A, they already helped us out. It says write an expression for Jesse's rate using J for the number of hours she would take to mow the lawn by herself. So a rate is really easy to write. It's just the job over how long it takes them. So let's circle that. The rate equals the job over how long it takes someone. Well, what is the job? It's always one job. And so your numerator is always 1 divided by the hours it takes that person to get it done. And that's their rate. They can get one job done in this many hours. So here's Jessie's expression that we're trying to solve for how long it would take her. Her rate is she can get one job done, and we'll call the time it takes her J. Now it says write an equation to show the amount of work completed when they work together. Okay, so first of all, let's write Norton's rate. Norton can get one job done and his time is 4 hours. Plus, when Jessie works with him, right, her rate we wrote is 1 over J. His or her rate, not sure. And when you add their rates together, they can get that one job done in, they told us when they work together, it takes 2.5 hours. There we go. Norton's rate, one job in 4 hours, plus Jessie's rate, 1 over J equals the total rate, one job in 2.5 hours. So notice that this is pretty simple to solve, right? I need some more room though, so I'm going to write the same equation on another piece of paper. Here we go. 1/4 plus 1J equals 1 over 2.5. Okay, we know how to solve this equation. We're just going to go look at the denominators. Notice none of them are factorable, and we want to get rid of all of our denominators. How do we get rid of dividing by 4? We multiply by 4, and we multiply everything by 4. There we go. Let's look at our next denominator. How do we get rid of dividing by J? We will multiply by J. There we go. Last denominator, that's a 2.5. How do you get rid of dividing by 2.5? You multiply by 2.5. I'm going to use parentheses so I can see the decimal point really well. There we go. There we go. Let's go through and cancel any factors that are in the same in the numerator and denominator. In the first term, I'm canceling a 4. Second term, canceling a J. Third term, canceling a 2.5. There we go. So what's left in our first term is 2.5J plus what's left in the second term is 4 times 2.5, which is 10, equals what's left in the third term is 4j. So I will get my like terms together. I will subtract a 2.5j from both sides. And that's 10 equals 1.5j. And when I divide both sides by 1.5, this will equal Jesse's time that it takes. And I forgot my calculator. Let's see. I got it. I think I know the answer, but I didn't want to mess it up. 10 divided by 1.5. I believe it's 6.67. And it is. Okay, so 6.67 hours. It would take Jessie on her own. Let's fill that in. 6.67 hours. Let's just do a quick check and make sure that that makes sense. If it takes Norton 4 hours and Jessie 6 2/3 or 6.67 hours, is it possible together it would only take them 2.5? I think that that's possible. Let's go down to number 2. Jessie can weed a garden in 30 minutes. When Norton helps her, they can weed the same garden in 20 minutes. Makes sense. How long would it take Norton to weed the garden if he worked by himself? They want us to write an expression for Norton's rate using n for the number of hours it would take to weed the garden by himself. So we know that the rate then is 1 job over Norton's time. So that's 1 over n. There we go. B, write an equation to show the amount of work completed when they work together. We're going to add up Jessie and Norton's rate and get their total rate when they work together. So Jessie can get 1 job done in 30 minutes, plus Norton can get 1 job done in n minutes, and that equals a total of they can get 1 job done in 20 minutes. And C, they want to know how long would it take Norton to weed the garden by himself, right? So let's go ahead and write that equation and find out how long it would take Norton. There we go. To get rid of the first denominator, we'll go through and multiply everything by 30. I'll use parentheses again. To get rid of the divided by n in the second denominator, I'll go through and multiply everything by n. And last denominator, to get rid of dividing by 20, let's multiply by 20. Okay, you know what to do next. Go through and cancel out common factors, numerator, denominator. 30 cancels in the first, n cancels in the second, 20 cancels in the third. Let's go through and multiply what's left. In the first term, 20n is left. Plus, in the second term, 30 times 20 is 600. And in the last term, 30n. Let's get our like terms together. We'll subtract a 20n from both sides. We get 600 equals 10n. And when we divide by 10, we get Norton would take 60 minutes to do the weeding on his own. So as you can see, if you're really consistent, when you set up the equations and then when you solve them, it's a pretty quick job. Get it? Haha, for jobs equations. Have a great day.